Hi, I'm Professor Decker, and first of all, welcome to Concord University. Today we're going to be talking about drug dosage calculations and what you need to know. So I'm going to show you this PowerPoint. It's completely of formulas, and it tells you each formula, and I'm going to have examples. Now after you complete this PowerPoint, I suggest that you go to dosagehealth.com. I have the address right up here on the board. And they will also take you through each step if you're having issues with one particular formula or another. They also have active interaction as far as you can answer the question, you click to the next screen, and it will give you your answer, and you can see how the question is set up, and you can see the answer and see if you've received the correct answer. So what you need to know. So I made this PowerPoint initially for my class because the students were at a loss. And a lot of people see drug dosage calculation and they see this big word problem. They get overwhelmed. They don't think about what they're doing and they get the problem wrong. Welcome to nursing school. Drug dosage calculation will be on every single one of your tests. It will be on your HESI exams. It will be on your NCLEX exam. You must know drug dosage calculation and how to calculate the problem in order to get through your life as a nurse. You will always use this your entire career. Okay, so this is mass for mass questions. So we have a mass for mass questions. So how you set it up, your formula is what you have ordered, so what the physician has ordered, what you have on available to you, and then you just simply divide that, and then that is your y would be your answer. So let's go to the next slide. So here's an example of a mass for mass question. You see we have potassium chloride. Available is 10 milligrams per tablet. Potassium chloride, 40 milligrams is ordered. How many tablets would the nurse administer? So what we have ordered, I have it in red, so it's color-coded for you, those that like colors, so that it will step out at you a little bit more. So you have a 45 milligram tablet. That is what's ordered. You have a 10 milligram tablet. That is what is available. So you just simply divide, and then you have 4 tablets. Now make note of this. If your dosage calculation question is asking how many tablets or however many mLs or whatever the nature, you must write at the end of your number what the drug is, if it's a tablet or mLs or whatever. Because if you don't, the professors here will consider it incorrect. So let's take a look at the next example. The next example is another one. Great, mass for mass questions. We have low pressure, or metoprolol, 25 milligrams PO is ordered. I have this ordered. I have these kind of simple and broken out. Please make note, on your actual test, you're going to have to pull that information out in order to calculate your problem. Metoprolol is available in 50 milligram tablets. That's your availability. That's what we have on board. How many tablets would the nurse administer? So here we have ordered. What's ordered? 25 milligrams. What we have on board is 50 milligram tablets. So the answer is 0.5 tablets. That's our answer, 0.5, or it could also be considered 1/2 tablet. Now, let's talk about decimal points. This is very important in the nursing world because you can make a mistake and you can kill your patient, or you can send your patient to the ICU. You will feel forever guilty. You will never forget that patient. Decimal points are very important. You see how I have the 0 in front of that 5? So then that sticks out, 0.5. Many nurses have made mistakes over the years. We are all about research and all about education, evidence-based practice. There have been nurses that's done their calculations the wrong way. They do not see that decimal point because why? It's so teeny tiny. So you need that 0 in front of your answer. Again, I have tablets. So let's go on. Now this is a mass for liquid question. So there's different formulas that we have in the dosage calculation world, and all of these, this presentation today, there's other ways that you can do it, but we're solely concentrating on formulas. Given a mass per liquid, how much liquid would you require? So our formula is ordered, what we have, ordered divided by what we have times the volume per half equals Y. Equals Y is the liquid that's required. So oftentimes with these types of calculations, we need to convert our micrograms, milligrams, grams to kilograms, and this is an example how. So if it is going to the right, you're going to multiply by 1,000. So for example, 0.1 gram times 1,000 equals 100 milligram. So this might be a little bit confusing. Well, let's just go on to the next slide because I have an example and it's kind of broken out a little bit better and I have it color-coded so that you can understand. So phenytoin is a dilantin. It's 0.1 grams PO is ordered to be given through a nasogastric tube. So this is what's ordered, 0.1. And if you look, it says 0.1 grams. I'm going to have to convert that. But I'm going to go ahead and read the entire question so I can make sure that that's what the doctor is asking, because I'm just not really sure. Always read your question twice. Always calculate twice. It's better to be thorough than to make a mistake and to either kill somebody, be written up, have an incident report. It happens. Okay, so we have 0.1 grams PO is ordered to be given through a nasogastric tube. Phenytoin is available as 30 milligrams and 5 mLs. So there is actually the amount of drug that is in 5 mLs is 30 milligrams. So how much would the nurse administer? Well, I just don't know how to do that question, so the first thing I would need to do is, because what's my availability needs to match what is ordered. So I'm going to have to do a conversion. So please note, on some of your math questions, you're going to have multiple steps. So what I'm going to do, I'm going to convert 0.1 grams to milligrams. It's going which way? Which way of the scale it's going? It's going this way. It's going to the right. So I'm going to multiply by 1,000. 0.1 grams times 1,000 is 100 milligrams. Guess what? I have matching now. Now I can calculate my problem. I have what's ordered is 100 milligrams, which is the same equivalent as 0.1 gram. Remember that little decimal point? Oh, and I have a 0 there, so then it sticks out. So if I didn't have that 0, for example, I might make a mistake and just have 1 gram. So we need to be very studious and pay attention to our problems and our nursing orders. So I have 100 milligrams, so I'm going to divide it by 30 milligrams, and then I'm going to multiply it times 5 mLs. Just the same way that my formula states, volume per half. So that is my volume, 5 mLs is in 30 milligrams. And then I get my answer. My answer is, I'm going to give the patient, I'm going to administer 16.7 mLs. Now here, it says mLs. That's how my answer should be. It should be mLs. So I have mLs down here. Remember, if you don't do that, you're going to get marked wrong. You may have everything correct. You miss a problem, you miss a step, you're going to get it incorrect. Our professors here at Concord are very thorough, and we like to see your work. Now we're going to do amount and IV fluid questions. Given amount of IV fluid, so this is fluid concentration, there's several different types, but just pay attention to what the question is asking and you can't go wrong. So given amount of IV fluid and the dosage expressed percent, what is the mass of the particular dosage? Well, my formula is always going to be my concentration percentage divided by 100. The 100 remains stationary. It does not move for this particular math calculation. So times 100 times the volume in ml equals my Y, which it's always going to be in grams. So this is a little bit confusing, right? Can't really figure out what we're doing. I probably lost some of you guys. So let's just go to the next slide, because you know I like examples. I like to teach by examples. So calculate the amount of dextrose in 1,000 ml D5W. That is my math question. So my concentration, I made a boo-boo, but here dextrose is always 5%. I didn't put that up there for the newbies, but I'm just telling you now. So 5% is my concentration. 100 is stationary. It always stays there. So I'm going to take my 5, I'm going to divide it by my 100 times 1,000 mLs, and I come up with 50 grams. So there is 50 grams of dextrose and 1,000 milliliters of D5W. The D5W is dextrose, and it's most of the time it's 5%. Look at your order, and your physician will keep you on track with that, with what he wants or she wants. My next one is another example. So that one was pretty straightforward and easy. So this one, I put calculate the amount of sodium chloride and 2,000 mLs of NS. NS is sodium chloride, or also known as normal saline. But typically on the bag, it's like NS is 0.9% NaCl, which you should already have that base and that knowledge, so you should know that NaCl is sodium chloride. So I'm taking my concentration as 0.9% divided by 100 times 2,000 mLs, which is 18 grams. So let's think about this. Our concentration, or our crystalloids, do not come in a 2,000 ml bag. We're going to purposely trick you up to see if you're paying attention and if you know what you're doing. Some of you may totally skip this 2,000 and just put 1,000, and then you're going to get your answer wrong. Read your answer, take your time, read it twice, then calculate twice. Calculate and then check. This is another example of a formula. It's called volume divided by time minus the IV ml rate, or equals the IV ml rate. Given a certain amount of liquid in a time period, so these orders are usually the physician orders a certain amount of fluid over a time period, and we need to know the IV flow rate. So what is the necessary IV flow rate in mLs per hour? The measurement is used when the IV is regulated electronically by the infusion pump. Now, we're spoiled, because back in the day, when I was a nurse, we had to manually calculate, and we didn't have the pumps, and we had dialer flows. So you guys are very fortunate to have these electronic pumps. But if the lights go out and you do not have enough red outlets for emergency, and if our city is in a state of an emergency, or we're under hurricane watch, we may not have that when you're working. So you also need to make sure that you can calculate your fluids manually. So we'll go over that, and then that's, of course, another class. So your volume is your ml. My volume is my ml up here. And my hour, I'm going to divide it by my hour equals my flow rate in mLs per hour, because the question is stating mLs per hour. So, well, I'm probably still losing you guys. So most of you guys are visual, or a lot of the population of our nursing students. So I have an example. So I have here, so you can actually pull it out. So I decided, well, let me just make this a little bit more interesting. And then this way, I'm drawing your eyes to where it needs to go. So 250 mLs is what I'm supposed to infuse over the 120 minutes by the infusion pump. Okay, now this is my formula, but the time needs to be in hours, not in minutes. So my question, that's being asked, is given to me, is in minutes. So it's a simple calculation. I take 120 minutes, I divide by 60, because there's 60 minutes in an hour, and then it's 2 hours. So I have 250 mLs divided by 2 hours equals 125 mLs per hour. See my mLs per hour? So I don't want to get my question wrong. You have to always put that. And the reason why I'm homing in on this is because 50% of my students failed their last test, because they did not put that on there, even though I went through the same PowerPoint. So I'm just trying to make note. I'm homing in what's the importance of this. Okay, volume divided by time. Here's another question. Ordered 1,000 mLs, 1 liter, of D5W IV to infuse in 10 hours by the infusion pump. So when you see infusion pump, that's usually electronic, just FYI. So I have my volume is 1,000 mLs. My time is 10 hours. I don't have to calculate because it's already in hours, because my question, my formula says time in hours, so it's already figured out for me. But if this was in minutes, then I would have to do that extra step of my formula before I even started my formula. So 1,000 mLs divided by 10 hours equals 100 milliliters per hour. Volume time. Volume time equals the IV drop rate. So yes, they're getting a little bit more complicated, right? But it's okay. We have a formula for those even complicated ones, excuse me. So we have a certain amount of liquid with a certain amount of time and a drop factor. Our drop factor is GTTS/mLs. What is the necessary IV flow rate in GTTs per minute? You're going to get these questions. You're going to get questions that have extra, what I call fluff. We want you to be able to critically think and pull what you need from the question and calculate the problem correctly. So pay attention. That's why I say read twice. So I'm going to, this formula is I'm taking my volume times the ml divided by my GTT per minute times my drop factor, and then I have this goes down here, but just for sake of this, because my slide was too small or my typing was too large, it's flow rate and time, okay? Flow rate and time, see? What is the necessary flow rate in GTTs per minute? Okay. My formula. So here is a problem. So it's all color-coded. So it draws your eye so that you pull the right thing out. Please note on test, our professors do not color-code anything. So make sure you're paying attention. Calculate the IV flow rate for 1,200 mLs of normal saline to be infused in 6 hours. The infusion set is calibrated by a drop factor of 15 GTTs per ml. So my formula is my volume divided by my time multiplied by my drop factor gets me my flow rate in GTTs per minute. But I have 6 hours. This particular formula is time in minutes. The previous one was time in hours. So you need to really read your question before you can apply which formula will work, because if you calculate the wrong formula for the question, you will get it wrong. It will not be right. So I'm just simply taking 6 hours multiplied by 60, so it's going, if anything goes to the right, it's multiplication. If anything goes to the left, it's division. Simple, simple, easy peasy, right? So 1,200 mLs divided by 360 minutes multiplied by 15 GTTs per ml, my answer is 50 GTTs per minute. So that is my infusion set drop factor rate. That is my correct answer. So now I have volume, time, IV drop rate, volume and time. So here's, hold on, did I skip this slide? Oh, no. Okay, I provided 2 examples. Okay. Getting back on track. Sorry, guys. So calculate the IV flow rate for 200 mLs of normal saline, which is 0.9% normal saline, and this is an IV given over 20 minutes. The infusion set has a drop factor rate of 20 GTTs per ml. My formula is, I'm going to take my volume, and I'm going to, you have to look at the blue here because with my slide. So my formula is my volume divided by my time with my drop factor, multiplied by drop factor gets my Y, which is my answer flow rate in GTTs per minute. So you can look here, and I don't have this one in green, but if you see here, 200 mLs, so that's my volume. 120 minutes is my time, and that's in blue, and that's in blue. Times my GTTs per ml is 20. So that's my the lavender here, or the purple. And then my answer is in black. And this is my Y, 33 GTTs per minute. So here's, I thought this might be a little bit interesting, and if you look on dosagehelp.com, this is our go-to site. This is listed throughout the campus, and actually in most of our rooms, it's listed. So if you ever get stuck and you just lose the professor and your mind's not there for whatever reason, go home and look at this, and you can do, there's multiple endless problems, practice problems. So practice does not make us perfect, it makes us more proficient, it enables us, we're enabling ourselves to be better test takers. And then better nurses in the future, because we're going to be nurses. So this is the weight. This is a required daily fluid. I'm not going to read all this, but different hospitals have different policies. So right now you're in Concord, right? Concord Institute Career, right? Career Institute. So I call it our Concord Hospital. When you're in Concord, we're going to do as to what our dosage calculation books state. Now, mind you, if I'm working at a local hospital, the required daily fluid per kilograms, and that's weight, may be different. But for the sake of this training, and we're at Concord, this is Concord's required daily fluid. So 0 to 10 kilograms is 100 ml per kilogram. And then you can just go down 10 to 20 is 1,000 plus 50 per each kilogram above 10 kilograms. 20 to 70, 1,500 plus 20 per each kilogram above 20 kilograms. Over 70 kilograms, they're going to need 2.5 liters or 2,500 mLs, and that is the adult requirement. The reason why I'm putting this out, you know there's multiple step questions coming, right? Or multiple step, there's questions that you have to do multiple steps to be able to answer your question appropriately, to do your calculation. So this infant weighs 4 kilograms. What is the required amount of fluid per day in ml? Well, the required fluid is 0 to 10 kilograms, right? Per 100 mLs per kilogram. So I'm going to take my kilograms, 4 kilograms, multiply by 100 mLs per kilogram, and then that's my requirement, 400 mLs. That's my fluid. Oh my goodness, you mean Professor Duggar, you're really doing this to us? Yes, I am, absolutely. How else are we going to learn? Because there's questions like this. We're going to have to do multiple steps before we even get to our formulas, and you're going to have to be able to calculate. An infant weighs 30.8 pounds. What is the required IV flow rate in ml per hour? So I know that my answer's got to be in ml per hour to maintain proper fluid levels. So first, I have to convert. I have to convert my pounds to kilograms. So how am I going to do that? Okay, so this question is going to the left. So if it's going to the left, you divide. If it's going to the right, or the scale is going to the right, then you multiply. So I'm taking my pounds to kilograms, so I divide by 2.2. So 30.8 pounds divided by 2.2 is 14 kilograms. So that's one step of my question. So I have my 14 kilograms. 14 kilograms minus the 10 kilograms is 4 kilograms. So it's 4 kilograms over, because this is my rate. So 10 to 20 kilograms, right? 1,000 mLs per 50 ml per kilogram above 10 kilograms. So I'm taking my 1,000 mLs, and then I have to take plus 50 mLs per kilogram multiplied by 4 kilograms, and that is my answer. It's 1,200 per day. But I have to do another step. It's a multi-step. I know. I'll give you a little hint at the end of this PowerPoint of what you need to do to make you successful with your test. So don't fret now, just take a deep breath and relax. Now this is an ordinary, plain Jane rate question. You're going to take my volume, I'm going to divide it by my time, and then that's going to be my flow rate. So there's 24 hours in one day, right? So one day is times 24 equals 24 hours. So there's my mLs per day. That's what's required in the whole day that we had already calculated. So that is going to be my volume. My time is always done in hours with this particular formula. I'm going to divide my 1200 mLs divided by 24 hours, and I'm going to get 50 milliliters per hour. So that's my answer. So I had to do a multi-step problem. So there's multiple steps. Multiple steps you're going to find mostly is in pediatrics or anything that we have to divide by, we have to calculate the weight or maybe the medication, so there's different steps. But I have a little special tidbit that everybody needs to do that might help you. So this is dosage by weight, another formula. There's many, and you have to be able to choose which formula you're doing. So this is given the weight of a patient and a dosage specified by weight. So these are weight-based medications. So we have to know the weight of our patient. These problems, most of the time, like I just said, are pediatric. Our weight is in kilograms right here, and we multiply by dosage per kilogram equals my Y, which is my required dosage. So it's still a little bit confusing, so we're gonna do a question here. A doctor orders 200 milligrams of Rocephin to be taken by a 15.4 pound infant every 8 hours. The medication label shows that 75 to 150 milligrams per kilogram per day is the appropriate dose range. Is the doctor's order within the desired dose range? Okay, so we have to put on our nursing caps. Sometimes our doctors order things and it may not be correct. So if you go ahead and you give something that's not appropriate or with not in the required milligram per kilogram per day, it's not appropriate for the child, and you give that medication, who's at fault? You are, the nurse. So you always must check. Anytime that I've had a pediatric patient, and I've dealt with a lot of pediatric patients throughout my career, I double check. Then I triple check I check with 2 separate nurses to make sure that my dosage calculation is correct so that I don't do harm to my patient, so I don't harm the child. It's extremely important. I can't say that enough. So weight in kilograms, and actually with any patient to be honest with you. Weight in kilograms multiplied by dosage per kilogram is my Y, which is my required dosage. So this question is actually giving me this order, and it's asking me, is the order safe? Is this order safe? Did the doctor do the correct order? If he didn't, I might have to call the physician, but we don't know that yet. My first step is I'm going to take my pounds and I'm going to convert to kilograms. So my pounds is going to kilograms, so I'm going to divide, because it's going to the left, divide by 2.2. So if you see any problem from pounds to kilograms or kilograms to pounds, you know your magic number is going to be 2.2. You just need to know if you need to divide or if you need to multiply. In this case, we're dividing. It's a division. So 15.4 pounds divided by 2.2, my child is 7 kilograms. So now there's another step. Now I'm not finished yet. So I have to take 7 kilograms and I have to multiply it by 75 milligrams per kilogram up here, and that's 525 milligrams. That's my minimum desired dosage because 75 is lower, right? So now I have to do another calculation, and I'm taking the weight of my child again at 7 kilograms, and I'm multiplying by 150 milligrams per kilogram, which is 1,500 milligrams, which is my maximum dosage. So this 75 milligrams per kilogram per day, so that's my range, that's my minimum, that's my maximum. I had to calculate my problem out further, and here it is, 525 milligrams and 1,050 milligrams. So that is, the order should be within that desired range. I have a third step. 24 hours is in one day. The medication is ordered every 8 hours. So if I take 24 hours, because that's my time period in one day, it has not changed since the start of time, 24 divided by 8 is 3 times a day that the doctor ordered this medication. There's another step. I know, it gets lengthy and it gets tedious, but you have to make sure you do your calculations correct. So I'm going to take 200 and I'm multiplying by 3 is 600. 600 milligrams ordered by day. So I look at 600 milligrams ordered per day. Is that within the desired range of 525 and 1,050? So yes. So I've just done everything, all these calculations, all these steps, and I've forgotten what the question even asked me. So let's go back and we read. Let's see, what is it? Am I still supposed to give this? No, that was not my question. My question was, the medication label, there's my desired range, 75 to 150. Is that the appropriate dose? Did the doctor's order within the desired range? So my magic number, after all this information, the child is going to be getting 600 milligrams per day. Per day, the doctor, yes, he has ordered the dosage within the desired dosage range. Here's another one, dosage by weight. Dosage by weight. So we have Solumedrol. It's 1.5 milligrams per kilogram for a child that weighs 74.8 pounds. That's the weight of my child. Solumedrol is only available in 125 milligrams per 2 mLs. So I have 125 milligrams of medication in 2 mLs. How many mLs must I administer? Well, this is a weight, so I'm going to take my weight in kilograms and I'm going to multiply by my dosage per kilogram to get my answer. So the first thing I'm going to do is I have to take my child's weight, pounds to kilograms, and I have to divide it by 2.2. So 74.8 pounds divided by 2.2, my child's weight is 34 kilograms. Then I have to take the weight of my child in kilograms and I need to multiply it by my ordered drug. So, or my order amount, which is 1.5. So I'm taking 34 kilograms multiplied by 1.5 milligram per kilogram, and it equals 51 milligrams. So now it kind of changes. So I'm doing 2 formulas. Yes, this does happen, my God. I'm just being honest with you, just giving it to you how it is. This is an ordinary mass per liquid question now. So I had to do my steps here. I had to do 2 steps before I even get to my formula. So if you're doing a drug dosage calculation and you miss a step and you just go straight to the formula, guess what? You get it wrong. It's not going to be right. So this is my formula. I have my order and I divide by the volume and then that's my Y. So the Y is my answer, which is the liquid required. So 51 milligrams is ordered. Because that's how I got this, right? 51 milligrams, I had to take the weight of my child, had to do all those calculations, and the medication is available in 125 milligrams in 2 mLs. So here I have it color-coded. So 51 milligrams is what is ordered. That's what I need to give. Divided by 125 milligrams, what I have, multiplied by my volume, which is 2 mLs, and then my answer is 0.82 mLs. Now, when you have children or when you have weight dose calculation methods, make sure you know how to operate your syringe. I have my decimal point here, my 0. Don't be that nurse that just pulls up 1 ml and gives it because you're going to be doing harm to your patient. And you could get in trouble. Like your patient could get in major trouble. Because weight dose medications are very important. That's why there's orders where they're given by weight. So now we have mass divided by time is our IV ml rate. So we have another formula. So this is given an order quantity of mass per time. And I need to determine what my IV flow rate is per mLs per hour based on the given mass per volume. Now that sounds like a bunch of blah, 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 and I'm probably going way over your heads, but you know I like to give examples of my problems, but here's our formula. Now this is a formula because I have several years of ICU, Trauma 1 and PACU and all those good things. in critical nursing underneath my belt, and this is a formula that I used a lot. Actually, I probably used all of them within that practice or within that field, but this is one that was very often. So I have my order, is what's ordered per hour, and I multiply by what I have, or excuse me, divide. I take what I have ordered, and I divide by what I have, and I multiply by my volume, and that equals my IV flow rate, which is mLs per hour. So of course, you know, I like to have color codes. I like to pull it all out so it draws your attention. Give the patient 500 milligrams of dopamine and 250 mLs of D5W to infuse at 20 milligrams per hour. And you're looking at this question and saying, oh my goodness, really? Yes, this is the real world of nursing. Welcome. Calculate the IV flow rate. So first I'm like, let me look at this again. So where is my order per hour? Well, I just don't know. Say I don't know, but I'm like, well, my formula says order per hour, so I'm going to look for my hour. Oh, per hour, 20 milligrams. So 20 milligrams per hour is what is ordered. Then what I have is 500 milligrams, right? And 250 mLs. And usually, sometimes the thing is written 500 milligrams / 250, and it might have dopamine in the beginning or dopamine in the end, but you need to be able to relate these two go together. So I'm going to take 20 milligrams per hour, divide by 500 milligrams, and I'm going to multiply by 250 mLs, and my IV flow rate per hour is I'm going to only give this patient 10 mLs per hour. So I have another formula, another one I know, and it's a multi-step. So this one is ergotat. It's to be given as 12.5 milligrams, and 250 is prescribed, and it needs to be infused at a rate of 6 mics per kilogram per hour. They're getting a little bit harder, right? A little bit more detailed. Just hang tight with me because we also have a formula for this. So my patient weighs 100 kilograms, right here, 100 kilograms. At what flow rate in mLs per hour am I going to set the pump? A lot of times we just get this medication from the pharmacy, we get this order from the physician, and you actually have to do drug calculation at work, right? And then anytime you do drug calculation, you always have another nurse check behind you regardless of what it is. Just FYI, that's my strong suggestion there. And it's not that you're incorrect, but you can make a mistake, and it's better to have 2 sets of eyes or better than 1 pair of eyes. The first step, so this is a multi-step question or formula or process. You want to call it a process. The first step is to convert the order per time and the amount required for this particular patient. So this is a dosage by weight question because I see my kilograms up there, so I automatically know that. So I need to find out what my weight is in kilograms. So 100 kilograms is the weight in kilograms, and 6 mics per kilogram per hour is the dosage of the drug. So I need to give 6 milligrams per kilogram, and then I have 100 kilograms. Well, I'm still lost, I just don't know what to do, but here's my formula. So here's my weight in kilograms multiplied by dosage per kilogram equals my Y, which is my required dosage. And I'm going to do mLs per hour because that's what the question is asking me. How many at what flow rate in mLs per hour? So I've already got that in my head. Then I need to put that at the end of my question, so my answer, so that my answer is correct. So I'm going to take 100 kilograms. I'm going to multiply by 6 mics per kilogram per hour. My answer for that first step is 600 mics per hour. Then I'm going to take and convert. I have to take my mics per hour and I have to convert to milligrams per hour. Anytime that you have a question, and if it's in a different form of what you have on board and what is ordered, you need to convert to make them match. If you do not, you're going to get it wrong. Okay? So here's mics to milligrams to grams to kilograms. So it's going to the left, so I'm going to divide, right? So I'm taking 600 divided by 1,000, and I'm going to get 0.6. Well, there's my little decimal point. I'm going to make sure I put my 0 in front, because if I don't have it, I might miss that there is a decimal point in the front. So I'm going to take 0.6 milligrams per hour, and I'm going to divide it, so that's what I have ordered per hour, 0.6 milligrams per hour. And if you notice, it's 6 mics per kilogram per hour here, but we've done all of our conversions. Actually, what I have is 12.5 milligrams, that's my medication. I'm going to take my 0.6 milligrams per hour, I'm going to divide by 12.5 milligrams, and I'm going to multiply by my volume, which is 250. My rate is going to be 12 mLs per hour. So that's my answer. This is the end of the show. So this is what I want to say to you. Everybody tells me, Professor Duggar, there is no way humanly possible that I'm going to remember all of these formulas. And you want to know a secret? I maybe know most of them, but if I don't do my drug dosage calculation every day, I forget. And I've been a nurse for years. And this is true for nursing. Whatever field of practice that you're in and whatever you do on a daily basis, you become proficient. Never perfect, but proficient. But if you stop doing something, you lose. You lose your skill. So just to keep abreast of it, what I do is I have a cheat sheet. Now, I do not take this to class, but I use it as a study tool. So anytime when something's going to the left or the right in all my conversions, and I have all of, well, I don't have them up there now, but I have all of my formulas written down. Mass per mass, mass volume, etc. And I just write everything down. Now, over the years, I can remember 2.2 is my magic number for calculation of weight, but I may forget, well, how do I do grams and milligrams? There's different ways that you can do it, but with this particular learning session, is you either multiply or divide by 1,000. You write that sheet over and over, you read it out loud, you look at it, you write it over and over, and when you go take a drug dosage calculation test or any test, I dump. I call it dumping my information. I memorized it in my brain, but I may get overwhelmed with all the questions because they're big wordy problems. We're going to purposely put more information in there to mess you up. Maybe not to mess you up, we want to make sure that you're doing it right. We want to make sure that you're critically thinking. So I take all my paper and I write all my formulas out. I don't have a piece of paper with me to class, I don't have anything in my pockets, I'm not cheating, and I call it dumping the information because they will let you have a piece of paper. I write every single formula out. Then, by the time that I get finished with this, half the class is already up at the front, turned in their things, right? I'm still writing down my formulas, but I'm okay, no sweat. Not going to let that bother me because I'm the type of person, I want to see it. I want to take that information, I want to take my time. I'm going to read my problem twice before I even calculate. Then I'm going to calculate, and before I calculate, I have to look at that, and I look at my dumping information, I look at my scratch paper, I choose which formula is going to be the solvent for the problem. Then I do my problem according to which formula. Then I do it again. So I write it on paper because the teachers, the professors want to see your work. And I do it again, and then I do it with my calculator. If they let you have a calculator. Sometimes they do, sometimes they don't. Just depends on the professor. So you better make sure that you're proficient in your division and your multiplication. But if you just take your information and you dump your information on your sheet before your test, then you can take your test, and I will guarantee you this will get you through your career and your student process so that you can become a nurse. So again, key point, this is a very good site, dosagehelp.com. It will help you tremendously. They have an endless question bank. You answer the question, they give you instant feedback on whether you've gotten it right, as well as the formula. They'll give you the formula. So say maybe you got the question wrong because you're using the wrong formula. So if you take these little itty-bitty hints that I'm giving you, you'll be successful in your drug dosage calculation. Thank you and have a great day, and welcome to Concord.